Hello everyone, welcome to section 3.3 on dividing polynomials. So recall what we were doing in the last section. In the last section we were graphing polynomials, and we really needed two things to graph a polynomial. We wanted to know its end behavior. Does it look like this? 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 We have four options for the end behavior, but what we also needed to figure out is what was going on in the middle. And the way we figured out what was going on in the middle is we took advantage of trying to find the roots of the polynomial, or the zeros, or the x-intercepts. They all mean the same thing. So all the examples that we had in the last section, we either had the polynomial already factored for us so we could find the roots, or the function had to be, or the polynomial had to be pretty friendly. It had a greatest common factor that we could factor out. Maybe it was a quadratic that you could factor. Maybe it had four terms. You could use grouping. But what if we don't have those nice situations? How are we going to factor polynomials? How are we going to find the zeros? And that's really what we're going to be doing in the next three sections, 3.3, 3.4, 3.5. We're going to be building a tool on how to factor polynomials. And the main tool that we need is we need to know how to divide polynomials. So this section here is really a tool that's going to help us find the zeros or the roots of polynomials when we can't use our regular factoring skills. Okay, so a little bit of vocab. So for example, let's say I have 132 and I'm going to divide that by 5. Maybe we're asking ourselves, how many times does 5 go into 132? So we can set up a long division. Set up our long division. How many times does 5 go into 132? So let's recall how to do this. So we'll ask ourselves, how many times does 5 go into 1? 5 doesn't go into 1. So we'll ask ourselves, how many times does 5 go into 13? 5 goes into 13 2 times. 2 times. And then we do 2 times 5, that'll be 10. So we'll record a 10 right here, and then we subtract. So we'll take the 13, we'll subtract 10, and we'll get out a 3. And then we bring down the 2. So we'll have a 32. And we'll repeat the process. How many times does 5 go into 32? I hope you believe it goes in 6 times. And then we'll do 6 times 5, we'll get out a 30, and then we'll subtract. And we'll get out 2. Okay, notice now that 5 does not go into 2, so now we're done. So what we have here, move this over a little bit, is we have that 5 goes into 132 26 times plus the extra 2/5. The rest of the division I couldn't go any further with. So here's some language with the pieces that we have here. We call this 132 here, this is called the dividend. Dividend. The 5 here we call the divisor. The 26 is what we'll call the quotient. And just the 2 here, not the 5, the 2 here is called the remainder. So there is some vocab. So when we end up doing the, dividing polynomials, the algorithm is very similar. Okay, so if we're doing polynomial division, if we want some vocab with the polynomials, let's say I take a polynomial p of x, and I want to divide it by another polynomial. For now, we'll call it d of x. So p of x would be our quotient, would be our dividend, and d of x would be our divisor. And when we do the division algorithm, we're going to get out the quotient. We'll call that q of x. Plus, we'll have the remainder over the divisor. So again, this p of x, this would be the dividend. d of x would be the divisor. q of x will be the quotient. R of x will be the remainder, and this will also be the divisor. So what I'd like to say here is when we end up doing the division algorithm with polynomials, how do we know we're going to be finished? We're going to be finished if the degree of the remainder is smaller than the degree of the of the divisor. So we stop, maybe in red, we're going to stop the algorithm when the degree of the remainder is less than the degree of the divisor. That's when we'll stop. So before we go on any further, what I would like to comment on is why does this turn out to be helpful for us? Well, notice here for a second, if I do polynomial division, if I divide these two polynomials together, let's say that I were to multiply both sides by the divisor. So let's say I multiply both sides by d of x. And notice what will happen here. So when this multiplies in, the divisors will cancel, so I'll be left with a p of x is going to be equal to, this will distribute in, I'm going to get a q of x plus the divisors here will cancel, sorry, q of x times d of x, plus the divisors will cancel, plus r of x. So why is this helpful, or what are we hoping for when we do polynomial division? So here we are, hanging out, hoping and praying when we're doing polynomial division. What do we hope for? What do we hope for? We're hoping, we're praying, oh please! We say please, please, in capitals. Please, let the remainder be 0. Oh, this would be great if this was true. Why would this be great? Why would this be great? Looks like my smiley face has a mustache. Why is this great? Well, if the remainder is 0, if our wish comes true, if this is 0, if r of x is 0, then we'll have that the polynomial p of x would just be equal to q of x times d of x. So I've taken this polynomial p of x and I've broken it down into two smaller polynomials that are multiplied by one another, which essentially means that I was able to factor p of x into two smaller polynomials. Oh, this is what we want to do. So this is the motivation, and we'll see this with examples. Let's get to it. How do we do polynomial division? We're gonna do some examples. Okay, our first example. Let's say we want to divide. Let's say we want to divide 2x squared minus 5x minus 1 by x minus 3. Let's say we want to divide these two polynomials. So in a similar fashion, we're going to set up a division bar. So x minus 3, and we're going to divide that into 2x squared minus 5x minus 1. So this is how the algorithm goes. What we're going to do is we're going to look at this x, and we're going to ask ourselves, how many times does x go into 2x squared? Or another way to think about that is, what do I need to multiply x by to get a 2x squared? I hope you believe that that'll be a 2, and an x. So 2x times x gives me a 2x squared. So what we do now is we multiply 2x by the x and by the negative 3. And what we'll get is 2x times x, I'll get a 2x squared. 2x times a negative 3, I'm going to get a minus 6x. So now what we're going to do is we're going to subtract. We're going to subtract these two polynomials. Now, if you would like, you could think that there's kind of this extra plus 0 right here if you like, or you could just leave a space to think that there's a blank there. Either way would work. But we're going to subtract. So notice if I'm subtracting, what I like to do here is I like to distribute the minus sign in, and instead of subtracting, we'll add. So what I like to do is I just like to flip the sign. So this was positive, now it'll be negative. This is negative, now it's positive, and now we'll add. So I'll get a 2x squared plus a negative 2x squared. I'll get a 0. I'll get a minus 5x plus a 6x. I'm just going to get a single x left. And you can think that I have a negative 1 plus 0, so I'm just going to get a negative 1 left. So now what we do is we repeat the process. So we ask ourselves now, how many times does x minus 3 go into x minus 1? So we look at the x and we ask ourselves, what do I need to multiply x by to get an x? I hope you believe that's a 1 plus 1. And now I take that 1 and I multiply it into the x and into the negative 3. So I'll get an x minus 3. And now I'll subtract. But instead of subtracting, I'm going to distribute that minus sign and flip the signs. So when I add these together, I'll get a 0, I'll get a negative 1 plus 3, I'll get out a 2. And we're finished. And how do I know we're finished? Because 2, a constant, you should think about that a 2 or any constant like 3, 10 or something is a 0th degree polynomial. It's a 0th degree polynomial because I guess you could imagine that there's kind of this x here, but it's an x to the 0th power. Recall that anything to the 0th power is 1. So this is a 0th degree polynomial. This is a 1st degree polynomial. This is the remainder is of a smaller degree than the divisor, so we're finished. So the final answer here, we have that 2x squared minus 5x minus 1 divided by x minus 3 is equal to the quotient. It goes in there 2x plus 1 times. And then we add the rest that we couldn't divide. The remainder, 2 divided by x minus 3. So this is the answer. Let's do another example. Let's say we have 2x cubed minus a 9x squared plus a 15, and let's divide that by 2x minus 5. So don't pause the video quite yet and try this on your own, because what I want to talk about is what happens when our dividend, the polynomial, it's missing a term. Notice here it doesn't have an x term in here. So what you either want to do is you want to either record a space or you want to record a 0 times x. So what I would do here is I would write this as 2x minus 5, and we're going to divide that into a 2x cubed minus a 9x squared. I'm going to write a plus 0x plus 15. So again, you could leave a space here. I usually like to record a 0x. So this is a good time to pause the video and try this out on your own. Okay, let's give it a shot. So we'll first ask ourselves the question, how many times does 2x go into 2x cubed? Or I like to ask myself the question, what do I need to multiply 2x by to get 2x cubed? I think we need just an x squared. So let's write an x squared. Okay. And now we'll take this x squared and we'll multiply it into 2x minus 5. And so what we'll get is we'll get a 2x cubed and a minus 5x squared. And now what we're going to do is we're going to subtract. So when we subtract, we're just going to flip all the signs. And now we'll add these two polynomials together. So I'll get a 2x cubed plus a negative 2x cubed, that's a 0. Here I have 5x squared, and I'm taking away 9x squared, so I'll be left with a minus 4x squared. I'll have a 0x plus 0, so how about I record a plus a 0x, and I'll have a 15 plus a 0, so I'll add a 15 here. And now we repeat the process. We'll ask ourselves the question, what do I need to multiply 2x by to get a negative 4x squared? I think we need to multiply it by a, what, a negative 2, a negative 2x. So now I'll take this negative 2x and I'll multiply it into the 2x minus 5. So we should get a, what are we going to get? We're going to get a negative 4x squared, and then we're going to get a positive 10x. And we'll subtract. But by subtracting, I'm just going to flip all the signs. So how do we do that? So adding these together, negative 4x squared plus 4x squared, I'll get a 0. If I do 0x minus 10x, I'm going to get a negative 10x. And then 15 plus 0, I'll get plus a 15. Okay, we'll repeat the process. So let's see. So we'll ask ourselves, how many times does 2x go into negative 10x? Or what do I need to multiply 2x by to get a negative 10x? I hope you believe I need a negative 5. So a minus 5. So we'll do the negative 5 times the 2x and the negative 5 times the negative 5. It looks like we'll get a negative 10x plus 25. And then we're going to want to subtract, so I'm going to go ahead and flip all those signs. And then we'll add, so here I'll get a 0. 15 take away 25. What do we get there? I think we're going to get, what, negative 10. And this will be our remainder. Okay, so we're finished. Because this is a 0th degree polynomial and this is a 1st degree polynomial. So what's the answer? The answer is the quotient, x squared minus 2x minus 5, plus we have our negative 10 all over a 2x minus 5. And we're finished. Here's our answer. The quotient is 2x squared minus 2x minus 5, and the remainder is negative 10. Okay, let's do one more example. This one's a bit spicy, but it's great. Go ahead and pause the video, give it a shot on your own before we do it together. Okay, so I'm going to set this up. I'm going to write x cubed plus 4. I'm going to divide that into an x to the 6th. Now, just as a comment, when I set these type of ones up, I only usually like to add like the 0x to the 5th or add in the 0 coefficients for my missing terms for the dividend. I usually don't like to do that for the divisor. You can just leave spaces. You'll see in just a second. But if I add zeros in here, you can if you'd like, but it really just takes up so much space, more space than you really need. So I'm only going to write in zeros for the dividend. So I get x to the 6th, plus I'll have a 0x to the 5th, plus a 3x to the 4th, plus a 0x cubed, plus a 0x squared, plus a 5x minus 8. Okay. So what do I need to multiply x cubed by to get an x to the 6th? Looks like I'm missing 3 x's. So an x cubed, and I'll multiply the x cubed by the x cubed, so I'll get an x to the 6th. I'll get an x cubed times 4, so I'll get a 4x cubed, and I'm just going to line that up under the x cubed spot, so I'll get a 4x cubed, and then I'm going to subtract. Now what I'm going to do here is I'm going to pretend that there's like a 0x to the 5th here, a 0x to the 4th, a 0x squared, a 0x minus a 0 or plus a 0, doesn't matter. So when I subtract, I'll flip the signs. I'll get a 0, I'll get 0x to the 5th, I'm going to get a 3x to the 4th, I'll get a minus 4x cubed, I'll get 0x squareds, I'll get 5x, and I'll get a minus 8. And we'll repeat the process. Okay. So what do I need to multiply x cubed by to get a 3x to the 4th? Looks like I'm missing a 3 and an extra x. So I'll do 3x times x cubed. So I will get a 3x to the 4th. And then I'll get a 3x times 4, so I'll get a 12x, and I'll line that up under the x spots. So I'll get a 12x. And we'll subtract, again, pretending that there's a 0x cubed here, a 0x squared, and a plus a 0 here. So I'll flip all the signs, so then I can just add. I'll get 0x to the 4th. I'll get a negative 4x cubed plus a 0x squared. 5, let's see what I'll get, I'll get a negative 7x minus an 8. Okay, repeat the process. What do I need to multiply x cubed by to get a negative 4x cubed? Looks like I just need a negative 4. Okay. So I'll multiply the negative 4 by the x cubed. So I'll get a negative 4x cubed. And I'll do a negative 4 times the 4, so I'll get a negative 16. So I'll put the negative 16 here. I'm going to subtract, so I'm going to flip the signs. So I'll be left with 0x cubed, 0x squared. I'll be left with negative 7x. And then I'm going to get plus 8. And now we're done. I have a first degree polynomial here for my remainder, and my divisor is a third degree polynomial, so we're done. So our answer is going to be the quotient, which will be x cubed plus 3x minus 4 plus our remainder, which is negative 7x plus 8, negative 7x plus 8, all over x cubed plus 4. And here's our answer. Hope you enjoyed that. We'll see you in the next video. Take care.